So this is an update on the power inverter by Simon. I kinda got it working. I also figured out how to get in the menu. Well, maybe it's because I did connect the thing the wrong way around once, and it's kinda dodgy now, but I have found a way how to get into the menu, and it is, you have to do some kind of brownout on the microprocessor and keep spamming this button, and then I can get into the menu. I will do that, and since this is not an edited video, I will place the camera on my laptop and I will try to get into the menu, and then I'll show you the menu from the inverter. So, okay, let me try it. So, oh, there we go. I got it on the first try. So this is the menu from the inverter. The first thing is a step. This is the step in which you can vary the voltage. For example, you can vary it in 1 volt, 10 volt, 20 volt steps. So let's go in number 1. And this is where the way how far you can align the voltage. So you can align the voltage on the output from the inverter, and the voltage that you control with these buttons will be then the voltage that is on the output. And so I can eventually, okay, that was the wrong button. Let's try it again. So there we go. So I can, with this button, I can decrease it. And with the other button, I can increase it. So let's stay in 20 volts per step, which is pretty much the maximum I can do. And the third button saves it. So on the third button, if you push it, then it saves it. The other thing is the voltage if there is no load connected on the inverter. So I haven't yet figured out how exactly that thing is working, because I can go to it and it says empty run voltage 230 volt, which is the voltage in Germany. And here is the SW. I have no idea what this means. Maybe it's the sweep or something. And I can also change that with the buttons. And it does not really do much. So I guess I don't know what it's supposed to do, but I tried it. I think I could change the output voltage. Maybe that's the output voltage, and I tried to change it, but it did nothing. So there was no change at all on the multimeter. Okay, and there's a third option, which is the so-called, if you want to translate it, it's like alignment. If you go into this by pressing this button, you can get into a menu where you have these numbers, and you can change these numbers, and you may ask, what are these numbers for? Well, I can tell you. Let me see how bad I am prepared. Oh, I'm not that bad prepared. There is the schematic. I thought I will show you the schematic, but it's laying somewhere else in my room. I think I do have the permission from Simon to show you the schematic, since there is no code involved in the schematic. Anyway, so here we go. So here it says the dividing factor is 1065, and I changed some stuff which I will explain to you. And therefore it's not 1065, because Simon told me that when he uses a different processor and makes the same program on that microprocessor, he gets different results with 1065. So I have the option to change that number here, and this will then later involve, or better, this will later have influence on the voltage regulation system of the inverter. So it will affect how well the regulation works and how far and so on. So I made it to 1001. I will tell you soon why, and I'll leave it like that. And if I now press the continue button, the inverter is going back into the menu. And if I press the continue button again, oh well, there is a contact bad now. But if I press the continue button again, the inverter will start. So now it's going to start, or it's going to restart. It did remember, or now it saves the changes that I made, and now it's going to restart. So it's climbing up to 230 volts, and it will stay there. I haven't yet figured out how to change that. Maybe if I push the button here, nah, it doesn't do anything. So I haven't yet figured out how to change the output voltage. But the idea from that inverter, the idea that Simon had, was that you can change the voltage on the output, and then it will stay on that voltage. Of course, in a range, you can't make 12 volt AC. I mean, you could probably make it, but it would be very unstable. Okay, I changed the heatsink from this transistor because it's very efficient and I don't need a big heatsink, so I changed it to a small heatsink, and for demonstration purposes, this heatsink is just fine. Also, there is this capacitor. It's an old vintage, don't ask me how old it is, capacitor. It's 180 nanofarads, and it's just smoothing out the output from the inverter a little bit, which helps stabilizing the overall circuitry. So it's generating a stabilized voltage. Then I've found out what are the potentiometers for. So this is an op amp, and this is like a voltage divider which gives a reference voltage to this op amp, and this is the feedback. So here's the feedback from the inverter's output to the circuit board input, if you want to call it like that. So this feedback potentiometer here lets me align some kind of level. If this level is, let's say, overdone, it will turn off the voltage, or it will decrease the voltage. Okay, so it says 230 volt on the display. You may remember the previous videos where it said any random values like 2 million volts or so. But now it says the correct value, and if you have a look at the meter, I'm in the 250 volt range, you can see that actually the voltage is quite accurate. So far, so good. But I'll be honest with you, I'm still struggling a little bit with the circuit and having trouble with it. This also isn't the video that I wanted to tell you that I make. When I make this video, I will probably replace these MOSFETs with better MOSFETs that have a lower resistance when they are turned on. And I will eventually add a second MOSFET to this one, or replace it with a better MOSFET so it can handle more power. So, okay, there are some problems. As you can see, the regulation system now works. And if I connect a load to it, this is just like a small LED light bulb. If I connect it here, I know some people may complain how I handle 230 volts, but I know what I'm doing. I've had a successful apprenticeship and that stuff. So anyway, so this is a small LED light bulb. It's like, let's see if there is a value written on it. Oh, it says 1.1 watts. And this is a small light bulb, so if I connect it, you can see it lights up. And if you look here, it will change. If I connect it, oh, it's making noises. If I connect it, it will change the PWM. So if I disconnect it, it will go down. And if I connect it again, it will go up. So the regulation system actually is working. And if you look at the voltage, you can also see that it stays pretty much stable. So it drops a little bit when I connect the light bulb, but it increases again as soon as I disconnect the light bulb. So far, so good. Nothing wrong there. But I'm having a little bit of trouble with this inverter. As you can see here, here's a voltage divider with a fixed resistor, but I replaced the fixed resistor with a potentiometer because with the fixed resistor I was getting like 210 volts or so out of the inverter and not much more. And that was not what I was intending to have. I wanted to have more volts. And so now with this potentiometer, if I turn it, I can change the voltage. For example, then it would say here on the meter, it would say 200 volts, but here on the display it would say 230. And so I aligned it that the display from the meter fits with the display from the inverter. Okay, the next thing that is a little bit dodgy is because if you connect a load to it, it will of course increase the voltage, but it will increase it to silly levels. This is a 25 watts incandescent light bulb. Let me connect it. Of course, there is enough power to light it up at full brightness, but look at the voltage. So here it says 210 volts, but if you look at the meter, we are over 250. So this is now with light bulb connected. And then it goes up, and it goes and goes and goes and goes over 250. The light bulb is getting hot, 260. So I disconnected because I don't want to pop the light bulb with over voltage. But as you can see, it's going up to silly levels. I could then go ahead and align it on the potentiometer so it goes back to the voltage which it is supposed to have. But then on empty run, we would have a lower voltage. And as you can see, the regulation system is very slow because it's just slow. So it takes a couple of seconds until it goes down to the voltage. So you could say, okay, let's adjust this potentiometer here because the thing obviously does something. So I'll turn it so now it seems to have more accurate feedback, if you want to call it like that, from the inverter's output. But now if I connect the bulb again, well, now it's even working, but it's still doing the same thing. So it's going to silly voltage levels. As you can see, it's climbing and climbing and climbing, and I better disconnect the light bulb before it pops. So I'm feeding the inverter with 12.8 volts from my power supply, which is a little bit less than a fully charged SLA battery, but which is an average voltage of a 12 volt battery. So it's like a good charge, but not fully charged 12 volt battery, which I'm supplying to the inverter. So it puts out the voltage, no problem. The power is there, so it can handle lots of power. Nothing wrong there, but something in the regulation system is either messed up or I just screwed with the values. I tried for it. I got it kind of working with my Christmas lights. I got it working so there was no bigger difference in the voltage from the output from the inverter due to in the relation from the input voltage. I mean, these two were pretty equal, either if I disconnected the light bulbs or if I connected them. But I just don't know. Okay, another thing I haven't tested it yet is because I want to show a different load. So you have seen these light bulbs here. This one, I would say it acts like a resistor. I mean, also the low power this thing has is not really something that the inverter cares about. This 25 watt bulb is like a resistor. And now I have an energy saver bulb here, which acts like a switching mode power supply. And one thing that inverters do with regulated voltage is that they mess up if you connect a switch mode power supply, because when you connect it, the switch mode power supply will decrease the voltage because of the internal capacitor. Therefore, the inverter will push more power into the transformer to equal the voltage again. The voltage increases, therefore the switch mode power supply consumes less current. Therefore, the voltage increases so far that it goes over the level from the inverter's output, wherefore the inverter will decrease the voltage again, what causes the switch mode power supply to pull more current. Therefore, the inverter increases the voltage again, and what you get is a blinking light, because it always increases and decreases the voltage. And this is one test I haven't yet made. So let's see if Simon's inverter can handle the bulb. It's not about the power. The power is like, what is it? 14 watts, nothing wrong there. But this is a switch mode power supply, and see what it does. Crackling noises by bad contact. Oh, there we go. It starts. Oh, and it oscillates. Look at the voltage. Now as I can see that the brightness is changing. But now we go. So this is, if I take now the screwdriver, and this one there, this one's reliable for this oscillation. If I align it like to a level that it needs more feedback voltage for stabilization, well, I have to say I haven't yet completely analyzed the circuit diagram of this thing. I'm just doing random tests. Anyway, now let's try it again, and it should stop oscillating. Now it's even worse. If I would get good contact. So now it's even worse. Look at the voltage. It's going way over 250, and then it goes down to like 100. Okay, so now I turn the potentiometer in the other direction. This one here, because this one obviously has something to do with the feedback from the inverter, with the voltage feedback. And there we go. Now let's try it again. So the voltage is changing again, so it goes on and off and on and off and on and off. So yeah, definitely I think I have to get in contact with Simon again so he helps me out. Also, I'd like to change the voltage here, so the output voltage. So I have no idea how to change it. I thought it was the second point that changes the output voltage, but obviously, when I tried it off camera, it does not do anything. So I adjusted in 200 volts, and it still went up like 230. So the last load I want to show you is a transformer, because it's like an inductive load. And here I have a toroidal transformer with a 20 watt halogen light bulb. And this is a 12 volt transformer. And now let's connect it and see what this one does. Well, lots of hum going on here. And the light bulb is on pretty bright. It's pulling more than 3 amps, and the voltage is rising and rising and rising and rising. So now I'll try to turn on this. So there we go. When I was over this level, the voltage went back a little bit, but now it increases again. Well, let me disconnect the inverter, because at 3 amps, so at 3 amps, this one, yeah, it's getting kind of warm. So you could see the inverter is basically working, so it puts out lots of power. That's not the problem. If I would replace these MOSFETs with better MOSFETs, because they are good MOSFETs, but they are definitely not the MOSFETs you would use in this purpose, because these are like 100 volt MOSFETs. They can handle like 10 amps or so each, or even more. I don't know it exactly. That's not the problem, but the problem is the high RDS on. So if they are switched on, they have a high resistance. And I would replace them with better MOSFETs, and then this inverter would have even more power. But still, as you could see, well, on one side now it works, the inverter is now working completely, but I still have issues with it. Probably my fault, because I don't know exactly how to use it. I haven't gotten a complete manual. I just was told press the third button to align it, but yeah. So this is Simon's power inverter, and yeah, thanks for watching.